that what we did yesterday? Talking about starting
All right.
again?
So what we did yesterday, we started on nomenclature, okay?
Oh, God.
So we started in on talking about the ions. Now you're going to find out the reason we did the ions is
Miss
what
Taylor
we're
asked
doing
in the
today.
first period to report to her classroom.
Dave, let me break it down for you. You're never gonna believe this. Nomenclature is literally just, you got a symbol, and you gotta tell him what it is. That's it. Absolutely simple.
Ah, man, it's easy peasy.
Easy stuff.
Here's the thing, when we look at this, why did we do the ions? We did the ions first so we can build. Do not fall for the trap. This is not as simple as it looks. The reason we did the ions first is so now we can talk about ionic bonds. So ionic bonds are cations and anions joined together. So whenever it comes to ionic bonds, how you're going to name them? We're going to name ionic bonds based on the cation and the anion rules. So you use the rules that I taught you from yesterday. This is how we're going to do this. But now that's the first key to this. You have to know how to use the rule. Now the important aspect is learning when to use the rule. Right. So whenever we look at this, how I tell people to examine this, for you all to know that it's an ionic bond. Here's how we know when to use the rule.
Yeah, it hasn't changed. I was
No,
hoping,
I was referring to mine down there.
well, I was hoping over his fellow break, he would come on and say kindergarten, like, trace the letter.
Maybe with the magnets.
So when it comes to using ionic bond rule, here's how we know to use it. First, there's two elements bonded together with no overall charge and two elements are a metal and a non-metal. This takes us back to knowing how to determine, distinguish between the differences between a metal and a non-metal. So whenever it comes to this, reminder to you, the staircase on your periodic table. Everything to the left are metals. Everything to the right are non-metals. If you have trouble remembering that, remember what group 1 is. Column 1, we call them the alkali metals. Column 2, we call them alkali earth metals. All of D block we call the transition metals, hence to the left of the staircase is metals. To the right is the non-metals. So we're going to go through a couple examples of these. You are familiar with this. Here's the key. Don't throw an answer at me because of repetition. I'm using examples that are familiar to you so that you can see you're familiar with the naming rules without knowing you're familiar with the naming rules. Got me?
Gotcha.
So the name. And then we add the formula. I'm going to give you the formula first on this one, because I know you can throw it out to me, but don't be so caught up on just throwing the answer out.
Or do you want us to soft toss?
Be a granny shot.
That's actually how I shoot free throws on the
They don't go in.
run. They actually do, so that's surprising amount. I've had a surprising amount of success with the one-handed free throw and the granny shot. Like, you wouldn't think it, but it kind of works.
Alright, so NaCl. What's it called?
One of them's chlorine.
No.
No, it's not. It's not.
What's another name for salt?
Oh, yeah.
Sodium.
Sodium chloride. Here's the thing.
Salt.
Salt. Just put salt.
You guys can give me that from memory.
Salt.
This isn't about memory.
I don't know. I didn't hear anybody answer that. I think.
We can give you
John
salt.
did.
Fair.
And I'm pretty sure Peyton did too, but he was
Yeah.
very quiet. Wasn't, I don't think he was 100% sure. I think he was nervous and scared. All right, you look at this. Here's how you do this, and you're gonna find, I'm trying to lay a foundation for you for whenever we have all the rules. I look at what I'm given, NaCl. Identify how many elements do I have? Y'all are still writing stuff, aren't you?
No, you're good.
Perchance.
Go ahead.
I'm gonna wait. No, go ahead, write. You need to write, but if I'm just gonna keep talking as you're writing, I'm killing myself. You're not gonna absorb the information I want you to absorb.
I have to pitch the principles and idea. Me and Mr. Hall, we're gonna record y'all's basketball games, and me and him's gonna do commentary. He'd be the color commentary, I'd be the play-by-play. Think about it. The next D&D sports.
Probably pretty popular on my reaction. I imagine if I announced basketball games like I did football games. The real West.
Have you ever been to Tug Valley?
No.
That's the way it is there.
Listen, the people get annoyed with me.
Ray. He has a really annoying voice though up there.
I've been told mine is too.
And he drags everybody down.
All right, so how many elements do I have? There's two. I have sodium, I have chlorine. So I have two elements. Is there an overall charge? No. What I'm saying when I'm saying overall charge is if you look at your polyatomic ion list that you have a quiz on next Tuesday.
Next Tuesday?
Yep.
I feel like I'm gonna be sick of that. No, that's a horrible idea.
That is an overall charge. So, there is no overall charge here. Now I look at the two elements I have, because what you're going to find out is there's a difference whenever we're going to name based off of if it's covalently bonded or ionic bonded. How do I identify if it's ionic bonded? Very simple. A metal and a non-metal. What is sodium?
No.
Sodium's a metal. What's chlorine?
A non-metal.
Non-metal, which means I name it based off of ionic bonding rules. When we use ionic bonding rules, we name the cation and the anion. So let's remember the cation, sodium here. How do we name cations?
By the element name.
By the element name. So we're going to name that based off the element name. Anions, how do we name that?
The element name without the ending, and we use it.
ID. You know who I am.
Hello? You're right.
He's actually talking about who wants to do it.
Drop some.
Is that very nice for me to draw? We can, we can go to next one. Yeah, we can talk to them.
All right, so anion. We take the element name, we keep the root, we remove the ending, add IDE. So we take chlorine, we keep the chlor, add I. Chloride. So we get sodium chloride. I know I'm boring you, but I gotta lay the foundation because this is gonna become a mess eventually. Okay? So
What's wrong with the neighborhood? What's wrong with the neighborhood?
the challenging thing with these is when you go from the name to the formula. So let's say I gave you
This Saturday, I'm gonna try to spend the whole day in hockey.
The whole day.
The whole day, just to see what's going on.
Let me guess. It's just CAF.
no.
Ooh.
You have calcium fluoride. Whenever you're going from the name to the formula, it gets a little more complex. So whenever we're going to go from the name to the formula, you got to write things out. And this is the reason as to why you have to balance your charges. Because you got to remember with these things, they're not being shown. Why are the charges not being shown? Because the charges are canceling each other out. So first start with calcium. So I look at calcium fluoride, I have Ca, fluoride comes from fluorine, that's F. Well, what's the charge on calcium?
Boom.
Two positive.
Yes.
Right?
Get a little bit of participation from the quiet corner today. Wouldn't mind.
Oh, four.
You look at calcium, calcium's in what column? Second column. Since we're in the second column tells us we are going to have what charge? Second column forms a positive 2 charge.
This class not being graded really is a travesty.
How do I hear that every year?
It just doesn't make any. This is a very tough topic, and I feel like the school should recognize it more.
Recognize my, like,
Well,
me or just chemistry?
recognize you and the chemistry. That is a difficult topic. You
I had a kid that told me one year that every class I taught should be AP and weighted. I was like, I'll take it as a compliment. What's the charge on the fluoride? The 7 is how many valence electrons it has. So what will it do to get 8? It'll gain
Negative
1. And what is electrons?
Positively charged ions.
Oh my Jesus.
Negative.
What are electrons?
It was negative particles.
Give it to me again. What are electrons?
Negatively charged subatomic particles.
Make sure the math department knows it. What is the electrons? Negatively charged subatomic particles. Can't stress that enough. So what happens whenever we gain electrons?
We get negative.
Okay?
-1.
What happens when we gain electrons?
You gain a negative charge.
You can form a negative charge. Everything is about getting how many valence electrons?
8.
8. We want 8. So you look at column 1. Now column 1, what they would do is instead of gaining electrons, they'll lose electrons. If we're going to lose electrons, we form what charge?
A negative charge.
Positive.
Positive.
You lost negative, so we form positive.
We're
So column 1 is a +1 charge. Column 2 is +2.
We'll let you look at that. It's +8.
Transition metals, freaky and weird. I skipped metallic bonds. They didn't get to talk about it, but they do something really weird called delocalizing electrons and just kick them out.
My favorite type of metals.
So they're out of here. All right, don't worry about them. We go to column 13. We look at 13. It forms a +3. Column 14 are weird. They only like covalence normally. Now, there are some exceptions down here at the bottom before anybody gets at me later on when we get to stuff later on in this lesson.
Nobody.
Then you break it over here. We get to column 15, and we switch. Now we're no longer losing the electrons, we're starting to gain the electrons.
Which gives us a negative charge, right?
That's right. So then we got the negative, column 15, we form at -3. Column 16, -2. Column 17, -1. 18th column, they got 8, they don't care.
Biyakasha.
Follow me?
Crystal.
You're scared from the children?
She ain't scared. Hannah.
That's not me.
Hannah.
Which probably should be.
Hannah.
I'm scared.
You okay?
That's a part of her bedtime.
What are you doing?
Went to the staircase now.
You're not sitting.
Is this her bedtime story?
Chemistry? No, we did, we was doing bonds last night. Tonight's gonna be Schrodinger's cat.
You got a cat?
No, she wishes we did.
She's gonna walk.
So, what will the charge on the fluoride be?
-1.
-1.
Thank you.
I called that at the start, if you remember correctly. Let the record show.
Now, here's the thing, we're gonna balance this out. There's a way to do this. Very simple.
There's a method to this madness.
Take the numbers, cross them over. Take the 2, comes down for the fluoride. Take the 1, comes down for the calcium.
All the one.
So whenever you look at it, we have Ca,
F2.
F2. Now when you bring the numbers down, we bring just the numbers.
Put it down there.
I love you.
Hey, are you gonna go play with Aubrey?
No.
Yes!
Yes, screw on.
Broke that.
Screw on. We don't like her. That's too much drama.
I don't know why, but randomly, like for the last 2 days, she's been doing great, but the last 2 days you ask her anything, she's like, milk? And I'm like, you want some milk? No! Okay. Then she like comes back forcefully. It's like, milk? Alright, anyway. So we balance these out by crossing them over. Now here is the interesting thing. Things do take place. So if you want it here, you can have it here. Things do take place that you have to simplify things out. David.
Why is there, why the 2 next to cat? If you put those together, wouldn't it be a +1?
Nope.
On the-
What's the charge on the calcium?
2.
It's a 2 plus.
2 plus.
So +2 times how many calciums are there?
1.
+2 times 1 is?
2.
+2. Fluorine has how many?
1.
2.
What's the charge on the fluoride?
-1. And they cancel out.
2 times -1 is -2. Add that together, you get 0. That's why there's no charge being shown.
Would you look at that? I understand it now.
Now, life can get a little complicated, okay? You gotta be able to simplify some things out. So let's say, for example, I give you calcium oxide. We're gonna do the same thing we just did. So we look at the calcium oxide. What we're gonna have is calcium and oxygen. Well, what's the charge on the calcium?
2 plus.
2 plus. How do you know it's 2 plus?
Because it was up there from earlier.
Because they're in the column of 2.
It's in the second column.
I think I said.
So it's 2 plus. What's the charge on the oxide?
Good question.
The
I want you to know something.
-2 is
Two, two mi- it's 2 minus! 2 minus!
That-
2 minus!
-2.
And I
2 minus! Woo!
I pray you have the greatest day, and I
Negative
cannot
2.
wait
Negative.
to get home to you later. I'm a blessed man. Thank you, Jesus.
I know.
Where were we at?
-2.
Oh yeah, oxide, right?
This is yours.
What was I talking about being a blessed man?
Oh, my.
Not only is she gorgeous, but she also bringing me food.
It depends what is it. What'd you get?
Oh, I
Oh.
just got it.
Hey.
What?
Oatmeal.
Hey, I love you.
I love you.
You have a
That's
great
fair.
day.
Spell it.
I really am going to try.
I know. It's kindergarten, right?
No,
What is it?
that's great.
Oh,
Well, it's even worse.
Oh,
You feel like you're have kindergartners. Where are you going to?
I'm doing my student teaching. I'm a Brian.
Probably. I think Morris.
No, it could be worse. No,
No, not really.
Could be worse.
That's a horse.
Dave could be the teacher.
That's true.
I'd be a grudge.
I meant like school-wise.
They'd have a great time.
No. My class would get a lot. It depends on what I'm teaching. If I'm teaching chemistry, then I'll learn anything. But if it's like reading or something, I can teach you
Alright.
guys some reading.
Calcium has a 2 plus, oxygen has a 2 negative, right? 2 plus, 2 negative. They balance out, love baby. They balance out and they cancel out.
Buddy.
So there is no cross. There is no crossing needing here, okay? Because if you cross it, if you did cross it, you would get Ca2O2.
That don't look
I
right.
don't need that.
You can factor a 2 out. That's not going to be right. The CaO is what's going to be right. So there's 2 methods to doing this. You can cross it, you can see the 2, so you can factor a 2 out, take it out. Or you can look at the 2 plus and 2 negative, it's a 1-to-1 ratio, done. CaO. Did I mention this was hard?
You might have brought it up in past conversations.
This is cake.
Free eats, something like that. My notes.
Kind of in a rough spot now.
Boom. That's what learning looks like right there. Now, if you know, I have an A in this class.
What'd you have last year?
Non-important.
Let me put those snow packets in.
No, we're good. We are.
Oh, you're putting the snow packets in? I was about to say,
One.
All right, here's the thing, okay? I do have something else I want to add before we get there, though. You do have your, oh man, did she not bring that?
How dare she? She didn't bring it, and then she brought the oatmeal to make up for not bringing it.
that's what it was. She forgot something, so she had to get some food to make up for it.
Common gaslighting thing.
Manipulation.
You have your lab tomorrow. I want to give you a heads up to this too. They have a thing they're wanting the leadership team to do, so we will not be by ourselves tomorrow.
Oh, God.
Mr. Short will be visiting us.
His class?
With Mr.
Not just
Gibson?
Mr. Short.
Okay.
No, Mr. Gibson's going to be watching the class.
Oh, thank you, Lord.
So Mr. Short will be in here while you're doing the lab. He'll be chill, laid back and everything. He's in here and he might have an iPad or a computer or something and it's all and he'll make the marks on me. Means nothing to y'all, don't worry about it. But I do want to go through and give you some background knowledge and refresh you on stuff that you're going to do tomorrow in the lab. Okay? So tomorrow's lab, what you're going to do is identify the types of bonds inside of different compounds. Now, I'm not telling you what the compounds are, because if I told you what the compounds were, then guess what? You would know.
Barbecue chicken in there.
So, you're not going to know what the compounds are. I'm going to label them out A, B, C, D, and I might have E. I think I have enough of it to do a 5th one. But there's different ways you can check and know what type of bonds there are. If you go way back, all the way back to December, we talked about bond characteristics.
Back, way back.
Push, 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 push. It's fine.
We talked about certain characteristics that we would see. Now, I'm going to go back through the characteristics that you're going to test tomorrow, because some of the characteristics you're not allowed to test because they're extremely dangerous.
Okay,
Aw.
See it?
I want to do a taste test on that.
So we're doing a avoid Kevin moments for tomorrow.
Yes, we want no Kevin moments. Okay?
We need to spice it up. We ain't have
Is it
very
like-
many labs. A Kevin moment wouldn't hurt.
For the Kevin moments, is the scream supposed to be like the Home Alone Kevin scream, or just more?
I love you. I want you to know that. I genuinely love you.
I think it's really gonna have it short until the point. Kevin.
If you
you have an emergency, it's supposed to be like Home Alone. Let it rip, bro. Come on. Alright, so different characteristics you're gonna look at, okay? So one characteristic is melting point. So whenever we look at melting point, in the fume hood, I'm gonna have a hot plate. Within the hot plate, I'm gonna have it turned up high enough for you to where you make the determination. I have some aluminum weighing dishes, and what you'll do, you'll split the aluminum weighing dish in half. You'll put some substance on one side, some substance on the other. And remember what happens melting point wise whenever we look at it. Covalent bonds have low melting points, and ionic have high melting points. Well, how do I know? It's very simple, actually. If it melts, it's going to be covalent. If it doesn't melt, it's ionic.
Chocolate's covalent.
Yep, he's got a point.
Now, another piece that goes with this, especially for one of the substances we'll have tomorrow, is smell/odor, however you want to look at it. Covalent bonds are very fragrant, so they have a high odor, while the ionics have a low.
What kind of bond is water again?
Covalent.
Yeah, oils and water is so very smelly. Like when I think water, I think, oh my gosh, that's a
Okay,
odor.
these are characteristics of bonds, does not mean it fits for everyone. I will go ahead and tell you, there are some tricks set out there that if you do one test, it'll tell you that it is something, and then all the other tests will tell you that it's something else. This is why you do multiple tests and identify the types of bonds that way. So we have the smell and the odor. Then we look at solubility.
What's that again?
Solubility is it will dissolve in water. So whenever we look at this, I will show you tomorrow because you actually have a testing kit that has some well plates in it for you to actually stick the solution in, put some distilled water, stir it up, see if it dissolves or not. So covalent bonds have a low solubility, while ionic bonds have high solubility.
Makes sense, because if you add water to water, it's just more water.
Now, while you do this, when you look at this, one thing that we examine, along with conductivity, solubility is conductivity. Bless you.
Thanks.
So the conductivity, whenever we look at it, covalent bonds have a low conductivity, so it really won't show up, while ionic bonds have a high conductivity. Okay?
And we're gonna be striking stuff like.
You actually have a conductivity tester that I'll show you tomorrow.
So yes.
No. It's not as fancy. as
Second
that.
caller to the office.
Yes.
So we have melting point, you have the odor, you have solubility, and you have conductivity.
He actually has a.
All of these are the four that you're going to test tomorrow. Now, you'll test these for every one of the substances. You'll examine every one of the substances like this, and then you'll make your conclusions. What type of bonds are in substance A, B, C, and D? Got me?
Yeah, I can imagine something. Do you have Tesla in your basement that you're gonna let us use?
You know how
Absolutely.
most of the science classes, they have like the sliding glass doors with a bunch of stuff in it? That's at Mr. Hall's house.
It's cabinets.
That's his cabinets. He drinks coffee out of the beaker.
Any questions? That's the lab for tomorrow. I actually ended up with extra time, which brings us to the fun one.
Taste. No.
We're still looking at ionic bonds, but there is a slight difference in change that'll take place with a certain group.
Just way in the hallway.
Okay.
He's about to ding dong the dish, I can feel it.
He just walked right by.
Who is it?
I don't know, he's got to turn the corner now.
Yeah, he must have heard us scheming. Was there anyone of it?
Let you go out there.
He could have stuck in there, kind of. Easy and wrong,
I said it from the corner.
Alright, so whenever we deal with ionic bonds that have transition metals, and remember what the transition metals are, they are the D block. Now I will go ahead and tell you there are some that are in P block that are included with this trend. So this is nomenclature with transition metals are involved. You're still dealing with an ionic bond. Since still ionic bond, bless you,
God.
use ionic bond
Thanks, guys.
naming. There's only one slight alteration. Transition metals can carry different charges.
Oh. It's like the office did it, where the office now, Scott's still there, take off.
Hence, in the name, we use Roman numerals to show the charge of the transition metal.
What does that have to do with the name? Oh, never mind.
There are no dumb questions.
What in the world am I talking about?
That is my least favorite thing somebody can say. There are plenty of dumb questions in on
Let me put my glasses on and make sure I'm seeing this right. Okay, that's
All right, we break this down. This is what I'm talking about. Iron 3 oxide and iron 2 oxide.
Oh no, that does not look fun to do.
It ain't bad, honestly. Yeah. Sorry, bro.
The Romans are dead, why are we still using the numbers?
What you do in this case, the Roman numeral tells you the charge on the iron. So I have Fe, what's the charge? 3, it's a 3 plus. Oxide, O, what's the charge on the oxide?
So negative 1.
2 negative.
Yep, that's what I said.
But look here, iron 2, Fe, 2 plus, oxide, O, 2 minus. This is why you have to do this. The charge determines everything for us. Things get switched around. Because in this case, we have FeO, that's iron 2 oxide. But over here, we have Fe2O3, that's iron 3 oxide. Tomorrow, we will do the lab. We should get the lab done. You will only have one day for the lab tomorrow. We wrap that baby up, we're finished. When we're finished, we're coming back to nomenclature, okay? So Bond ID lab tomorrow, come prepared and ready.
So are the transition metals ever negative?
No,
I always thought
they're
they're
cations.
dead.
We will go through this more.
Can't really